Hi, this is Mr. Hanna, and welcome to What the Format. Today we're going to go over some systems of equations, graphing, particularly solving systems of equations, but we're going to use the graphing method. There are actually three methods. We have graphing, substitution, elimination. This video will cover graphing, the next one substitution, and the final one elimination, or the addition method as it's also now called. So, first step, similar to what we've done in other videos, we're in standard form, we have to graph the line, so we have to go to slope-intercept form. Not always. You could graph these from standard form in some cases. If you want to do that and you can see when to do that, please go ahead and do so. I, however, like to try to be consistent, and I like to find a way that works all the time, and then I practice that way over and over and over and over again until it gets so easy for me and so natural it's like breathing. Then I'll switch it up. So in the case of lines, putting it slope-intercept form to me is the best way to graph typically, and it's the one that's the most consistent, works all the time, so that's the one I stick with. Now again, if you find a different way to do it and you like your way and it works, that's fine. That's actually what math is for. You start, somebody shows you what to do, you play with it. If you find a way that works better for you, you adopt that and then work with it. That's part of your learning process. Anyway, so here we're going to subtract the 3x. So if I take 3x plus 3y equals 6, I'm going to subtract 3x, those cancel. Now I got 3y equals negative 3x plus 6. I'm going to divide by 3, divide by 3, divide by 3. Those will cancel. Y equals negative 3 over 3 is negative 1, so that's now negative x. 6 over 3 is 2. So my line is in slope-intercept form. So I'm going to bring down the 2x minus y equals 7. I'm going to subtract the 2x, subtract the 2x. Now I have negative y equals negative 2x plus 7. Divide by the negative 1. And that's going to give me up here, I'll put it right here, y equals negative 2 over negative 1 is 2x. 7 over negative 1 is negative 7. These are now my two linear equations in slope-intercept form. I'm now going to graph them. So now notice this step is this problem. It's kind of long. I had to put that into slope-intercept form, put that one into it, and in the past, that was all you had to do for just one of them. Converted slope-intercept form, you were done. Maybe graph it, you were done. But now you had to do it twice. Now you got to graph it twice, and you have to be very careful. Okay, hopefully my scale is accurate enough that we can see where these lines intersect, because that's what we're looking for. So plus 2, I'm going to go to 2 on my y-axis. Negative 1 slope, so I'm going to go up 1, right 1, down 1, like that. Now at this point I might refrain from graphing it until I get the other one started. That's a personal choice there. Of course, now the problem is if I start putting more points in there, I want to make sure I don't get the lines confused. But a lot of times with the slope, if you go from here to the slope, if you follow the slope, you'll see where it lands, and it'll land at the same point as this one. So I can start there. The other way you can do it is you can graph one line and then do that, or you can just try to graph both lines and then see where they cross. Now, if you're on graph paper, graphing both lines is the way to go. The scale is already set. You got the little boxes, and you just make each box, the corner of each box is 1 point, and as long as you stay on that and use that and don't go in between the boxes, it'll work really well. So in this case, so what I'm going to do is I'm going to graph the first line first. So I'm going to come over here, and the challenge is to get it as straight as possible. Okay, it's a little light down there, but that's actually probably a good thing because I might have to adjust it. I might have to adjust it to see where it crosses. But now we're going to do minus 7. So 1, 2, 3, 4, 5, 6, 7. There's my, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And you should see this actually, down 1, down 1, the line should have gone through there. I didn't draw it straight enough. That's where the challenge comes in, especially if you're freehanding it. Now, if you're using a ruler, that tends to be a little bit better. But now you can see clearly where this line is going to cross that line, thanks to me following the slope. Okay, I'm going to walk through that again here real quick. Okay, so there's my intercept. Down 1 over 1, down 1 over 1. See that? Down 1 over 1. I should hit right there. Up 2 over 1, up 2 over 1. Up 2 over 1. See, they land on the same spot. And that's kind of what I meant about maybe waiting to graph it to see where they were going to go because their slopes at some point they should be coming together. And also with graphing, it has its limitations. Try graphing when one of the say like the x coordinate where they intersect is 3/7. How are you supposed to tell 3/7 on a graph? Unless it's a technology that you're using to graph it, and then trace it, and the technology tells you exactly where the point is. Trying to find 3/7 by hand is next to impossible. I guess you can get an idea where it is and then play with it, but of course that's a lot more work. So the graphing is kind of limited. 90% of the time, when you graph, there's going to be whole number answers, integers. Now, occasionally they might go to fractions like halves. Sometimes halves are not too bad to see on a graph. But why am I mentioning this? Because at some point you're going to be asked to solve a system of equations. They're not going to tell you which method to use. And you're going to have to choose for yourself. And if lines cross, they can cross anywhere in this plane. So you don't have to have nice, easy answers like 2, 5, or -3, -4. It could be anything. It could be 0.3478, comma, -0.1943. Now, clearly, if I get those answers, graphing isn't going to work for me very well. How do you know that? Well, if you just look at the equations, you might not be able to tell that. So one of the things eventually you're going to want to be able to do is choose between the methods. Now, like I said, I told you like before, with graphing, I like to always do slope-intercept form because it works all the time. Well, when it comes to solving systems of equations, unless I'm told specifically to graph, I usually go to the elimination or addition method. Why? Because it works all the time. Now, sometimes I'll go to the substitution method, and when I go over that, you'll see when and why. But the substitution method, even then, the elimination method is probably maybe easier because it's guaranteed to work in a certain way that when you see how elimination works, you're like, well, it's just easier for me to do this. Well, what's right and what's wrong? Well, if you're asked to do it a certain way, do it that way. And teachers are very particular. If they ask you to graph, they want you to graph. If they ask you to use substitution, they want you to use substitution. If they ask you to use elimination or addition method, that's what they want you to use. If you get to choose, though, that's where you're going to want to have some idea of what to do. And that's why I say if you start putting out your points and then you follow the slopes, if you can see it's going to be a nice integer answer like we just got, then continue with the graphing. If not, that's where you might want to say, oh, okay, graphing didn't work. Now maybe, well, I could do substitution here now. So even though I went to graphing, I could do substitution here. That would work really well. Elimination method, I could go back, erase it, and go back. But now you see the challenge. These problems require a lot more thought than I think maybe students are used to these days. And they're longer than students like. Students don't like problems. I don't necessarily like problems that take more than a minute or two to solve. But in reality, once you get into higher level math now, there are some problems. I've had problems where it took me 15, 20 minutes when I got to calculus to solve a single problem. And then I had to go back and check it, and I found I made a mistake and I had to go over it again, so it maybe took another 5 minutes to fix it. You have to, one of the things I hope you're seeing here is you want to train your brain on knowing what to do, when to do it, how to think through it. Don't rush through it. Just take it a step at a time. What I'm trying to show you here is the steps I use, so you have a jumping off place to build on. These are the steps I used. Put them into slope-intercept form. I then graph both lines. I can see that they intersect at 3, -1 here. So those are that's my solution right there. X is 3, Y is -1, right where they cross. And you can check them. 3 times 3, 9. 3 times -1, -3. 9 minus 3, 6. That works. 2 times 3, 6. Minus 1 is +1. 6 + 1 is 7. So that worked. And notice I'm using mental math to check them. If you need to write them out because you can't see what I just did, please write it out. Just plug 3 in for X, -1 in for Y. Make sure that when you do the math there, you get 6. Same thing on this side. 3 in for X, -1 in for Y. Make sure when you do the math, you get 7. And there you go. And that's how you solve with graphing. So step 1, make sure you're in slope-intercept form if you're not already. If you're in point-slope form, you can just graph from there. But again, maybe it's just easier to be more consistent, go to slope-intercept form all the time. I graph the first line, graph the second line, see where they intersect. Again, maybe you hold off on graphing or just sketch the line lightly until you can kind of see where they're going and make sure you line the points up. Because as you can see, my first line, it was a little shaky, it was a little off. See, not much, but you know, when you're doing your own scale, you don't have assistance, not using a ruler, that kind of happens. So then, and maybe you might be stuck in a situation you have to do that. You just want to have a system to kind of handle it. Notice I just took care of it, erased it, found where they intersected, used the slope, and there you go. Anyway, hopefully the steps here have been clear. You see them. Again, rewatch the video to see the steps if you need to. A lot of information there to absorb. Maybe write some things down, take some notes. When I then watch some of the other videos, see how it all fits together. And yes, it's a process. It takes time and effort to learn. I don't know any shortcuts to that. Some people pick up things quicker than others. Others it takes longer. But if you take it a step at a time, take your time and understand each step, and then practice it and memorize it, you can get good at math. Anyway, this has been Mr. Hanna with What the Format. Hopefully this helped you with solving systems of equations with graphing. Happy mathing.